Alright guys, as always, here are our in-class notes that we went over that were skipped on the original lesson. I left you guys A to do on your own. This is just straight Pythagorean theorem. Now we do want to get used to using our c squared equals a squared plus b squared now. And we know that c is always across from the right angle. So here I'm just going to use x. You can use c if you want, doesn't matter. C squared equals a and b, since we're adding them, doesn't matter which leg is a and which leg is b. So we'll do 3 squared plus 4 squared. Again, highly suggest go through and do this on your own. You learned this in junior high. We have x squared is equal to 9 plus 16. Then we add those together. We're going to get 25. To get rid of that square, that exponent, we need to square root both sides. And this comes out to a perfect square. Square root 25 is a perfect square. It comes out to a whole number of 5. Letter C, I set up for you. I set the triangle to the side, but here I just labeled what we needed. I'm not going to write the formula in this time. Here we've got C, so we've got x squared equals your 6 squared plus your 8 squared. Pause, guys, go follow exactly what we did on letter A and figure this out on your own because you're going to have to. So x squared is going to equal 36 plus 64. That total comes to 100. Again, we're going to have another perfect square, letting us know that x is going to end up being 10. A and C are also going to be triples that were talked about on the second page. We have a 3, 4, 5 triple, okay, because this came out to 5. C is also a 3, 4, 5 triple. How that worked, this comes out to 10. It's a 3, 4, 5 triple with a scale factor of 2. 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. And that's what we talked about in the video about our triples. The next thing is the converse of the Pythagorean theorem. The Pythagorean theorem is saying, hey, this is a right triangle. Find a missing side. You know, here's a right triangle. Here's your formula. Well, the converse, just like with your conditional statements, we talked about converse is switching the if and then. So now instead of telling you it's a right triangle, I want to know if it's a right triangle. So you use the formula to plug in and figure out, you know, if it comes out, if c squared is equal to a squared plus b squared. On the other video, what I should have done is not drawn in the 90-degree angles. I should have shown instead, you need to figure out what this is. Square root of 113 is going to come out to, you know, roughly 10 and some change. That way you can figure out which one is going to be the larger side. Over here with B, 4 square root of 95 came out to, I keep writing 8 for some reason, came out to a little bit more than 38. So we knew that this was going to be C. So when we go through and we plug in, we need to find out, does C squared equal a squared plus b squared? Well, C, we already said, was going to be 38. Now, we can't put 38. 38 is a rough estimate. It's an approximate number. You have to go back and you have to use your original 4 square root of 9. So we have 95. 4 square root of 95 squared is equal to a squared plus b squared. There we go. Remember here, all we need to do, 2 steps. When you're squaring a radical with the whole number, square the whole number, you get 16. Then multiply it by that radicand on the inside. 15 squared is going to be 225. 36 squared, large number, 1,296. When we multiply the 16 times 95, we're going to wind up with, I completely already forgot, 1,520. We're going to see if that's equal to the sum of 125 plus 1,296. Well, this sum over here actually comes out to 1,521. So what ends up happening here is we can't say that they're equal. So a very well-known math symbol is a slash mark through it, meaning not equal. So we can conclude here, therefore, not a right triangle. Sorry for the sloppy handwriting. You know my handwriting is usually awesome with all the colors. Lastly, if it's not a right triangle, well, what kind of triangle is it? We remember here in the video we talked about if c squared is less than a squared plus b squared, our angles are less than 90 degrees acute. If c squared is greater than, We have obtuse. So on A and B, we did on the video. On A and C. B, we need to first figure out if it's a triangle. So let's take our two smallest sides, compare it to our largest side. 6 plus 7. I'll write that out. 6 plus 7 is going to give us 13. This is going to be greater than the longest side. So yes, we have a triangle. Okay? So now we can go through our C squared, A squared, and B squared. I'm going to leave this little bubble because I don't know what symbol I'm putting there yet. It's going to be a less than, greater than, or equal to. So we already know here 8 is our largest number, so it's going to go in for C. Our little bubble, and then 6 squared plus 7 squared. Go through square everything. Now we just need to add and compare it to that 64. We come out with C squared, 64, is going to end up being less than A squared plus B squared, which became 85. So since we are less than, we can conclude, therefore, we have an acute triangle. Now looking at the next one, we still need to figure out if it's triangle first. So what we need to do is we need to figure out what these are, what these numbers are without the radicals. That way we're not, because we can't add them, because with radicals, if you don't have the same radicate, can't add them. So luckily, 2 of these came out to perfect squares, or 2 of them were perfect squares. Now your square root of 27 is very close to the square root of 25, which is a perfect square. So it's going to be just above 5. So we'll just put 5.1. I think actually this one came out to 5.19, so 5.2. So we add our 2 smaller sides here, and we get 7. We compare it to that 5.2. It is greater than, so yes, we have a triangle. So we move forward. Again, we have to go back to our original radicals here. Okay? We already knew that this is our largest side, so that one's going to go in place of C. So I'm going to have the square root of 27 squared. Put my little bubble. We'll put a symbol there later. Then we've got the square root of 9 squared plus the square root of 16 squared. So we recall with our square, with our radicals with no whole number, this is the most super awesome and easiest thing in the world. We don't have to worry about squaring anything. These cancel, and you're just left with 27. Same thing over here. Cancel. You're left with 9. Plus, cancel. Left with 16. So now we compare 27 to the sum of 9 plus 16, which will give us 25. Here we see 27, C squared is greater than A squared plus B squared. Since it is greater than, we say, therefore, we have an obtuse triangle. The end.